Okay, ladies and gentlemen, we are continuing our Math 1033 online lessons. This is the 4.3 lesson plan answer key. So, let us look. Here we go. All right. The first question asks us to graph y equals 2x. Now, if you recall, y equals 2x is an equation of a line. It fits the form y equals mx plus b. Y equals 2x, the number in front of the x is the slope, m is 2, which is actually thought of as 2 over 1. You don't see a number behind the x term, so we're going to assume that's a plus 0, which lets me know that b is 0. To graph a line, I start with b is 0. Remember, b is the y-intercept, so I put an ordered pair dot on 0. The slope is 2, which means from my b, I go up 2 spaces and over 1. I put another dot and I connect the line. Now this is really just a review of line graphing. Well, we need this. Notice this statement. Y is greater than 2x. This is not referred to as an equation. This is referred to, if you'll recall, as an inequality. Now, the way this inequality can be graphed, the solution set to it, we kind of tell a little white lie. Let's rely on what we know. Namely, we know how to graph y equals 2x. M is 2 and b is 0. So again, we start with 0 on the y-axis, that's b. M is 2, so we go up 2 over 1. This time, however, when we connect the dots, I want you to look at the original inequality here. Greater than does not have an equal to under it. Therefore, it means my solution set of ordered pairs does not include the points on the line. So the way you indicate that to the reader of this problem is you do not make the line solid, you make the line dotted. So I'm going to dot what I call my boundary line. Now, because we are told y is greater than 2x, we know that the ordered pairs that work, i.e. that are part of the solution set, are the ordered pairs above this line. So you see that where I'm shading in yellow is everything above the line. If it had said y is less than 2x, we would have shaded below the line. Okay, this graph is sometimes called a half plane because it literally is half of a plane, and it's a dotted line, so it's an open half plane. Some of your instructors may teach you to find the correct shading location by using a test point, but it's really unnecessary if you get y alone in the inequality first. Okay, let's make sure I'm on the next. There we go. Alright, suppose I'm going to graph y is less than or equal to 2x minus 1. Y is already alone. I kind of tell a white lie and pretend it says equals. I start with the boundary line. Y equals 2x minus 1. M is 2, b is negative 1. We know the line is solid because of the less than or equal to, and less than means we shade below it. So, negative 1 is my y-intercept. From there I go up 2 and over 1. I connect them with a solid line and I shade below. That's it. That's all she wrote. Now, this next problem, I don't like how it starts. 4x minus y is less than 5. My technique for solving this, for finding the solution set, will be to first isolate y. So my first step will be to subtract 4x from both sides of the inequality. That gives me the opposite of y is less than the opposite of 4x plus 5. To get y alone, I multiply by negative 1 or divide by negative 1. So every sign changes. You know, notice the This becomes a positive, this becomes a positive, this becomes a negative. But remember, when you multiply or divide an inequality by a negative number, you have to change the inequality sign, the direction. So it, quote, flips the sign, if you want to say that. So we're really graphing y is greater than 4x minus 5. B is negative 5, m is 4. Greater than means that since there's no equals, it's a dotted line, and we shade above. I start at negative 5. Remember, b is always on the y-axis. I go up 4, 1, 2, 3, 4, and over 1. I connect those points with a dotted line, again, since there's no equals under the inequality. And y is greater than, so notice the yellow I'm shading above the line. So I have an open half plane, open meaning the boundary line's not included. And that is my solution set, that set of ordered pairs. Remember, this information is going to become these types of graphs are going to become very important for you when you get into an area of both math and business called linear programming. This is what it's preparing you for.